Hello, algebra students. We're going to look at this test review today and mostly just do the odd problems in this video. The answers to all the problems will be posted on Canvas, but for the video we'll be mostly doing the odd ones and a few of the even ones. Okay, so let's look at number one. Simplify this expression. So when you have the same base, you add the exponents. So we see we've got b there and we've got b there, so we'll add those exponents. As far as the numbers go, you just multiply those. So we have a 4 and a 3, so we multiply that. 4 times 3. Okay, so that's 12. Then we look at those variables, and when we have the same base, we add exponents. Well, we have a to the third power, but there's no other a, so that just stays a to the third power. For the b, we have b to the third power, and we also have this other b, and remember, if there's no exponent on it, that's just an exponent of 1. That is there, even though we don't usually write it down. So remember, that is there. So we have b to the third power and b to the first power. Add the exponents, you get b to the fourth. Okay, and that's the answer. Okay, we will do number 2 because we don't have another example just like it. So we're raising this entire expression to a power. So we really just apply that 4 to each thing inside the parentheses. And for a number, that just means we have this -4 raised to the fourth power, and we calculate what that is. For variable, that is raised to an exponent, you multiply exponents. That is, you multiply that exponent that is on the variable times the exponent that's outside the parentheses. Okay, that's applied to the whole expression. So that's for the p, that's 3 times 4, which is 12. For the r, that's 4 times 4, which is 16. Okay, now we do have to further simplify it and go ahead and calculate that -4 to the fourth power. So it's a negative number, but it's raised to an even power, so the answer will be positive. And 4 to the fourth power is 256. So the whole thing looks like this: 256, p to the 12th, r to the 16th. Okay. So look at number 5. Oh, well, we'll do number 3. That's a fast one. We're doing the odds mostly. Anything raised to the 0 power is 1. So that's it. Okay, answer is 1. Number 5. Okay, now division. Well, we look for the like bases and we subtract when we're doing division. Numbers, you just divide. Okay, so it's this has the numerator has a negative sign, the denominator has a negative sign, so that just cancels. Negative divided by negative is positive, so the negative signs will go away. Numbers, well, all there is that 4 in the denominator, and that stays in the denominator. Okay, now let's look at those variables. If there was something in the numerator, let's say 12, we would take the 12 divided by the 4, right? And then we would have 3, and that would be in the numerator. But there's nothing else, so we just put down the 4. Okay, so now we subtract exponents. So we have this m to the fourth and m to the third. So subtract, so that's m to the first, right? 4 minus 3 is 1. So we don't usually write the exponent, it's just m. Look at the p. Well, there's no p in the denominator, so p just stays like it is. And the other variable we have is n to the fourth. Well, there's a couple ways we could do this. There's no n to the fourth in the numerator at all, right? So kind of just like we just left the p cubed there, the n to the fourth can just stay down there. Okay, now I'm going to show you this sort of long way to do it. We could subtract exponents, okay, and there is no variable n on top, right? We need that. Well, we could think of it as n to the 0 there, because anything to the 0, remember, is 1. We're just multiplying by 1 if we write down n to the 0, so we're not changing anything. And sure, then you have 0 minus 4 for the exponent of the n, and we would write that as n to the negative 4. Okay, but anything to the negative exponent, you make that positive, and remember, we're only going to be allowed positive exponents here. You make it positive by moving the base and exponent to the denominator and changing it to positive. So that's what we had a while ago, right? When we did it the other way, we just said, well, you've got n to the 4th down there, just leave it down there. Well, see, it ended up down there when we changed it to a positive exponent. So we're going to get the same thing either way. Okay. Number 7, simplify each expression. You guys are getting better about this for a while there. A lot of people would not see that plus sign, and you think, oh, this is one of those hard problems that's tedious and takes a while, where we multiply this by this. But no, it's not that at all, right? There is a plus sign in there. So this is actually much easier. All we'll do is combine like terms. Now, one like number 6, we would have to distribute that negative sign to each of those. So we're not going to do number 6, but this is negative 6x to the 4th, and then negative 2x squared. And then when you distribute that negative to the last one, it's negative of a negative. So it becomes positive 5x cubed. Okay, thought I'd just mention that. Ours, number 7, does not have a negative sign right there. It's plus instead. So we just add these. Look for like terms, where the variable and exponent is the same. That's the only one you can combine. So we look at the 4 into the 4th, and we also have negative 3 into the 4th, right? So 4 into the 4th minus 3 into the 4th is just into the 4th. And then we can cross those off, and when we do that, it helps us make sure there's no more into the 4ths that we missed, so looking good. So now we look at something else to combine, like terms, right? You have negative 5n squared, and you have plus 2n squared. Combining those is negative 3n squared, because negative 5 plus negative 2 is negative 3. So we've gotten rid of those, and now we just have negative 3 and 8. Okay, that's 5. So hopefully that's one of the answers. Looks like is B. Into the 4th minus 3n squared plus 5. So we say that's B. Okay. Find each product, number 9. So we have to distribute this. We're really distributing twice. We're taking the 7x times that. Okay, that gives us 56x cubed. And then we take 7x times the next one. Didn't draw that very good. So that's a negative, and it's 28x squared. And then 7x times the last one is 7x. Okay, now we take the negative 1 times each of those. So negative 1 times x squared, that's negative 8x squared. I'm sorry, negative 1 times 8x squared, negative 8x squared. Negative 1 times negative 4x is positive 4x. And then the negative 1 times 1 is just negative 1. Now we have to combine like terms. 56x cubed. There's no more x cubes. For x squareds, we have negative 28x squared and negative 8x squared. Add those together, and that's negative 36x squared. And then 7x plus 4x is 11x. We'll cross those off. And then you have minus 1. Okay, so that is that one. Okay, number 10, solve by factoring. Okay, so of course, 10 is the one actually we're not going to do because we're only doing the odd. It's the easy one, right? Easy one to factor. And you can look and see the solution once we get it posted, which will be probably tomorrow. Okay, so this number 11. Okay, this isn't so easy to factor. But to solve it, first thing we got to do is subtract that 7 from both sides. Okay, so that's going to give us 5r squared minus 29r. And then when we subtract 7 from both sides, we get minus 6 equals 0. Okay, so now we have to use the AC method for this. We want numbers that multiply to 5 times negative 6, negative 30, and add to negative 29. Okay, multiply to negative 30. I'll write that up here. Negative 30, add to negative 29. Well, that's kind of easy because 29 is almost 30, right? So they got to multiply to negative 30. So it must be negative 30 and 1, right? That will multiply to negative 30 and add to negative 29. So remember, what do we do with that? Well, that's because this is 5 here instead of just 1. Once we find that, we have to split the middle and then factor by grouping, and we'll have it. So 5r squared, we're going to split the middle, we said, into minus 30r and also positive 1r, because that's the two numbers we had. Negative 30 and 1 were the numbers that we found. And let's see, I'll write them over here actually. Negative 30 and 1. That multiply to negative 30 and add to negative 29. So we split the middle term, we finish up the rest of it, and that's it. We rewrote it, just splitting the middle term into those two terms. Okay, so now we factor out greatest common factor from that part and from that part. So the greatest common factor on the box on the left, that's 5r. In numbers, it's 5, and then you also have an r to bring out. Let's go ahead and find out this one, GCF. That's just, let's see, we take out a 1, of course, and really, sometimes you want to take out negative 1, but we don't want to this time. So yeah, we'll just say 1. Sometimes that's it. Okay, so let's factor out the 5, and we figure out what that's going to be by saying 5r squared. That was because that was the first term there, right? Divided by our 5r. And for negative 30, it's negative 30r, that is, divided by 5r. So when we factor out the 5r, what's left is what we get in these two division problems here, right? So we need to divide that. Well, that's just r. And we divide this, and that's negative 6. Okay, on the other one, we just factor out a 1. And so that just leaves it the same, r minus 6. Well, that's looking good. We did get our r minus 6 here like we wanted. And I'm going to have to sort of so I'll have to write down this down a little bit below on the next to fit it all in. So we factor out r minus 6 from that and factor out r minus 6 from that. And when we do that, see, I'll squeeze it in here. We have 5r and we have plus 1. Okay, the 5r is from there, the plus 1 is from there. So we've got it factored, and of course that equals 0. Okay, that's from up here, right? We set it to 0 and we factored the left side. Now to finish, we just say r minus 6 equals 0, or 5r plus 1 equals 0. So that is our two equations that we have to solve. Okay, so we add in this one on the left, we add negative 6 to both sides, r equals 6. One on the left, takes a little more work, right? So we got to subtract 1 from both sides. That gives us 5r equals negative 1. Then divide both sides by 5. R equals negative 1/5. Okay, so we have those two solutions, 6 and negative 1/5. And fortunately, that answer exists in our multiple choice, and there it is. Okay, so that's C. Okay, let's go on number 13. Write each polynomial in the standard form and then name each polynomial by degree and number of terms. So we have 3 of them here. We'll just do number 13. The answers are posted, will be posted for the others. Write it in standard form. That means descending order based on the powers of the variable. So the largest one goes first, and that's 5, right? So we write that term first. 3 into the 5th. The next one is the into the 4th, right? So that's plus 2 into the 4th. And then last but not least, we have minus 10 n squared. And so that's standard form. And then we have to name it, okay, by degree and number of terms. And so by degree, this is a quintic because that's 5. Degree 5 is quintic. And by number of terms, it's a trinomial because that has 3 terms. Okay, so a quintic trinomial. Okay, so let's go on. Describe the end behavior of each function. Okay, these are already written in standard form, and that makes it easier. When we graph these, we don't have them in standard form, and we have to think about it a little bit, but we can do that, and we'll talk about that when we get to the graphing. But these are in standard form. So to get the end behavior, you look at the first term when it's in standard form. That's the only one you have to look at, because that first term will be the one that has that highest exponent, right? If it's in standard form. If it's not in standard form, just look for that highest exponent. And that's the one to look at, the term with the highest exponent. You just look at the sign of the term, and you look at the exponent, whether it's even or odd. And that determines the end behavior. So you can look at the table. Why don't I'll go ahead and write a little quick version of the table over here. Sign positive, degree even. Okay. This is the end behavior. Okay, it's up and up, we could call it. So sign negative, degree even. That's when it's down and down. So when the degree is even, they're either both up or they're both down. Oh, I'm sorry, I wrote that wrong. I said it right, but wrote it wrong. Down and down, like that. Okay, sign positive degree odd. It's down and up. Down on the left side is down, and on the right side is up. And sign negative degree odd. You just reverse that. Up and down. Okay? Okay, so those are the 4 cases. We're just doing number 15, so we didn't really have to write them all, but it doesn't hurt. Number 15, sign negative, right, of that term that has that biggest exponent, and degree even. So that's this one. Okay, so the end behavior for number 15 is this. Okay. Okay. So let's go ahead and look at the next page. We'll have to save this real quick. And then bring in the other page. Page 2. Zoom in on it. And let's look at the next one. Okay, long division. We love long division, don't we? Okay, so let's write this up. P cubed plus 17p squared plus 65p minus 50 divided by p plus 10. Okay. Write that a little bit better. Okay, so we take the p cubed divided by p. And in class I did this a little bit awkwardly. I was saying, well, what do you multiply p times what to get p cubed, I think is how I was putting it, which is, I think, a pretty good way to think about it. But to make it, if you're having trouble with it, we'll do it the sort of simpler way and say just take p cubed divided by p. This divided by that. And you can just scribble that down to the side if you're having trouble with these. Okay, and I'm going to do this video especially for the people that are having trouble. So I'm going to be doing a lot of writing notes over on the side and things like that. So p cubed divided by p. Well, that's p squared. Okay, just subtract exponents. So we write that right here. And then we take p squared times this. Okay? And we write that down underneath. So I'm even going to write that over here. You don't have to write this down, but you know, it doesn't hurt. So we distribute this, right? P squared times P is P cubed. P squared times 10 is 10P squared. So that goes here. And you can do that trick where instead of writing it down exactly like it is, you write down the opposite of each of those and then add. But I'm going to keep this real simple and not do that trick this time. It makes it a little more tedious, but it will be doing everything in the more straightforward manner. So we write that down and we subtract, and notice I put parentheses around it. And now this is subtraction. So remember, the minus sign distributes. We have P cubed minus P cubed is just 0. And, you know, I won't write that this time. We'll be a little simpler. We just won't write the 0 down. We don't have to write it. So 17P squared, and remember this minus sign over here. It's minus 10P squared, so that's 7P squared. So now we take that and divide it by P. Each time we're dividing by P always. So 7P squared, let's do it over here, divided by P equals 7P. So that goes up here. And now we take that 7P and we multiply it by the P plus 10. So let's go ahead and actually write that down over here. And so that is 7P squared, we're just distributing this, plus 70P. Okay, so, and that goes underneath. But we also need to bring down the 65P, right? I didn't do that yet. Now, we write this down, what we just got when we multiplied, underneath here. 7P squared plus 70P. And we subtract that. Now when we did these in class, I wasn't doing all this writing off to the side showing exactly what's going on. So that's why I'm going ahead and doing it in the video. If you're having trouble with these, maybe that will help. So now we subtract. And again, 7P squared minus 7P squared is just 0. We won't write that down. We have 65P minus 70P. And we're kind of lucky here. We're not having negatives inside yet. I guess we won't have any. If we had minus and negative, of course, that would end up adding. But we don't. We have this time just 65P minus 70P, so that's negative 5P. Okay. And we will bring down the negative 50. Okay, so now we take the negative 5P divided by P. Negative 5P divided by P, and of course that's negative 5, so that goes up here. And then we multiply that by our P plus 10, right? That's what you do every time. So you have, it's negative 5. Remember, that's what we wrote down. Negative 5 times P plus 10. And that equals negative 5P minus 50. So that goes under here. And now we subtract that. Put it in parentheses. And it's the same thing as what's above, right? We're subtracting something from itself, so we know that's 0. I guess we at least have some negative signs in there finally, so we can talk about that to remind you how that works. We have negative 5P minus negative 5p. Well, minus and negative is plus, so negative 5p plus 5p, which is 0, like we knew it would be. Negative 50 minus negative 50. Well, it's minus and negative, so it's negative 50 plus 50. Again, 0. So this is 0, and there is no remainder. And so that is our answer, and hopefully we do have that on the left, and we do. So that's it. Okay, so we're getting there. Let's do just the odds. So, oh, there's only one synthetic division problem, and it's even. So let's go ahead and do it. Okay, so we accomplished the same thing that we do doing long division, but we do it with this convenient format. So what we write down, remember this is negative 8, so we write the opposite of that. We write positive 8 over here in our little box. And then we write the coefficients of each of these terms. So for the first one, that's just 1. The next one is negative 4. The next one is negative 29. The next one is negative 30. And then 52. Okay, then we write this bar like this. We get started by bringing down the 1. And then we start multiplying, add, multiply, add, multiply, add. So we take the 1 times 8. Every time we multiply, it'll be by the 8. 1 times 8 is 8. Add those numbers, it's 4. Take the 4 times 8, that's 32. Add those numbers, that's 3. Take 3 times 8, that's 24. We write it here. Add those, it's negative 6. Now take negative 6 times 8, it's negative 48. We write that here. We add and we get positive 4. And that's the remainder. We could put a little bar there like that. So these are the coefficients now. And the first term, remember, is one lower exponent than the highest exponent in the problem. And so it's v cubed, and the coefficient of the first one is 1. So it's v cubed, and then we just go down using these as coefficients. Plus 4v squared plus 3b minus 6, and with the remainder of 4. So we say plus 4 over v minus 8. And that is it. Okay. So number 19 says write an equation with the following roots. Okay, it shows the 0 twice. That means that the factor that root comes from, we have to square it. And that factor is just x. We could write it as x minus 0 and square that, but x minus 0 is just x. So that's a little bit extra to write that. Just write x squared. Okay, and then you have a root of 3, of negative 3, sorry. So that has to be x plus 3 is the factor that comes from. Okay, and then the 4 will have a factor x minus, let me erase that little underline, x minus 4 for that one. So it says write an equation. We could just say that equals 0. Okay, that's an equation. Well, no, let's not. I think equation has the following roots. I'm going to call this a function. I'm just going to say f of x equals Usually that's the way it will be. You'll have a problem, something like that. Um, yeah, I wanted to check the wording on the test. We would say either f of x or we would say y. So I'm going to squeeze this in here. Y equals, okay? And it would have those, the way we've written it would have those roots. Okay, one more. So this is graphing. And again, this is an even one, but we want to do at least one graphing problem because of course we do. So tell you, it's hard to draw straight lines on this. Okay, so we need to know the end behavior and we need to know the roots. Well, the roots are kind of the easy part, so let's do that first. For each of these binomials gives us a root. And so the first one, that would be -3, right? Because that's what it would take to make that binomial 0. Okay, so, and that's a double. So I'm going to write it like this to remind myself it's a double. Okay, next one is +6. It's also a double. Those are double roots because we have this exponent of 2 here. And then from the next one, it's of course +2. And the next one's -5. So we have those 4 roots. So -3 right there. +6 right there. +2 is here. -5 is here. Now we need to know the end behavior, and so we can graph this. Remember, we look at the first term when it's written in standard form, but this thing's nowhere near standard form, right? This is a bunch of binomials. To put this in standard form, we would have to multiply this out. We would have to take x plus 3 squared, and that would give us, you know, x squared plus 6x plus 9. But then we would also have to take x minus 6 squared, and then we would have to multiply those times each other, and we have a bunch of distributing and gather our like terms at the end. We're not going to do all that because we can figure out what we need to about the first term by just looking at it in this form. We need to know the sign of that first term, and we need to know whether its exponent is even or odd. So what is the sign? Well, that first term comes when you multiply all the x's by each other, is one way to think about it. That's when you're going to get that largest exponent. There's going to be a lot of multiplication going on here, but to get the largest exponent, you multiply all the x's by each other. And just look at the sign of the x itself. Do not look at the sign of the other number in the binomial, just the x. They're all positive. Okay, so the sign is positive. So we know the sign of our biggest term is going to be positive. The term with the biggest exponent, that is. So what is the exponent on that term? All you do is count the x's. Okay? So to get the sign, look for negative signs in front of the x. If there are none, the sign is positive. If there are some negative signs, an even number of negative signs is what would still give you a positive sign. An odd number of negative signs would give you a negative sign. Okay, so we know the sign, now we just count those x's. So this first binomial is squared, so that's going to produce 2x's, x squared. And the second one is also squared, that's 2 more x's. And then you have that's 4 altogether, and then from the last 2 binomials, this one and this one, they're not squared, so there's 1 from each of those. So we had 4 and then 5, 6. We got 6 x's when we count them. And you can also do the same thing just by counting the number of zeros. If you write them down to show the doubles like this, then you count those and they'll get you the same thing. So 6x's, that's even, so the sign is positive, the degree is even, and that tells us the end behavior is this. And now we can graph this. So when you're at the left, it's up at infinity, it comes down, and it gets to this -5. And is that a double? It's not a double. So it crosses. It probably goes down farther than we think it should. We're just guessing. It comes back and it gets to this -3. Is that a double? Ah, that is a double. So when it gets to that one, it bounces. Okay, comes back down. And we know it's going to come back up again because there's another 0 over here. So we don't know how far down it goes. Something like that maybe. Comes back up. And that's +2. Does it cross or bounce? That one is not a double, it's just a single, so it crosses. It comes down here to the +6 is the next one, right? It's going to come back down. We don't know how high it goes. Maybe something like that. Comes back down. Does it bounce there or cross? That's a double, right? So it bounces. And there are no more zeros, so it's not going to come back down again. It's just going to go up and up. And now we see, does that agree with our end behavior? Yes, it does, because we said it would be going to positive infinity. Okay, so that's what the graph looks like. And that's really it. I'm gonna, if you want to stay tuned and watch the rest of this video, I'm going to go ahead and bring this up on Desmos and see what it looks like when we get the actual graph. So let's take a look. If you're still with me, let's see. And I'll move this over so we can see both at the same time. Okay, so we have the graph there. And we have to type all that in. Just won't take too long. X plus 3 squared. X plus 3 quantity squared. Okay, and then we have, and it's kind of cool. It graphs what we typed. So x plus 3 quantity squares looks like that. Next, x minus 6 quantity squared. X minus 6. There's that. Now it's looking a little weird, but we're not done. X minus 2. And we got one more, x plus 5. Boy, this thing is swinging. What we have so far is really making some wild swings. Not surprised that it's doing that. So let's make sure we have it written, have it down there right. It's not all fitting. X plus 3 squared, and then times x minus 6 squared, and then x minus 2, and then x plus 5. Got to stretch that out so I can looks like it's there. And now I'm going to collapse. Now that I know that's correct, I'm going to go ahead and make that a little bit bigger. And now we're going to have to clearly zoom out to even have an idea what we've got here. You can look at our zeros and see if they look right. Well, you have -10 here, so this is -5, and there's -3, and then here is 2, and there's 5. Or no, 6. Yeah, 2, 4, 6. So that's 6 because 8, 10. This is 10. So we got the zeros in the right place. And you can see even from what we have here that we do have it right. It does go down and it crosses here. It goes down off the screen, comes back, and then goes to here, but doesn't cross, right? It bounces. So it goes down, and eventually it does come back, and it crosses here just like ours does. Okay. So you see, it crossed here, and then when we're supposed to bounce, we see it does bounce. It goes way down off the screen. And then, like I said, ours, what we drew, comes back here. This one does too and crosses, goes up off the screen. That's like this, but comes back just like ours comes back. This one comes back and goes to here, which is 6. And then it's so you can't even tell. It just looks like it stops. But if we zoomed in first, we could see it is bouncing and going back up. See, it's widening out. Those are two different. They're two. It came down and went back up. So it's hard to see. Let's go ahead and zoom out. Just see what it looks like. And it's hard to even look at because to zoom out enough to where you can see those turn around, it all just blurs together. Okay, so that one is hard to tell from the graph, but we could do it just by imagining that, yeah, it goes off the screen, but then it comes back, and then it turns around and goes off the screen again, but it comes back and then crosses, goes off the screen, comes back, bounces again. Okay, so that is it, and I'll see you later.